Hey there, algebra students. Today we are going to write equations of parallel and perpendicular lines. Finally hitting up target 4, compare lines to determine if they are parallel, perpendicular, or neither. That is our goal today. So one of your IMB cutouts, you have a little chart, and you should title it Parallel Lines. Now, if two non-vertical lines have the same slope, then the lines are parallel. Okay? So we have a given line, y equals negative 3x plus 1. We're going to graph this line in red. So then on our coordinate plane, we put our y-intercept at 1. And then since our slope is negative 3, we're going to go down 3 over 1, down 3 over 1, down 3 over 1. There is our line of y equals negative 3x plus 1. Now, lines that are parallel to this line need to have the same slope. So our focus is the fact that our slope is negative 3. So every single line that we draw, if they're actually going to be parallel, have to have the same slope. We do not care what the y-intercept is. As long as they have the same slope, then the lines will be parallel. So the second line, line 1, will be in blue, y equals negative 3x minus 3. Notice how the slopes are the same, but our y-intercepts are different. So when I graph this on the coordinate plane, there we go, same slope, negative 3, and then our line crosses the y-axis at negative 3. Now our second line, we're going to write in purple, we're going to have the same slope of y equals negative 3x, and let's change up the y-intercept to be positive. So then our y-intercept is at positive 5. So when I graph my line on the coordinate plane, I have my y-intercept at positive 5. So we go down 3 over 1, down 3 over 1, down 3 over 1. And notice how all three lines are, for the most part, parallel. They're accurately parallel. I mean, the only thing that I can say is that human error will cause the lines to not look as, I guess, perfectly parallel as they can. But the fact that each equation displays three lines that are parallel to one another. Alright, so example number 1, we have to write an equation of a line that is parallel. So it needs to pass through the point 2, 4, and it has to be parallel to the line y equals 4x plus 1. Now before, we didn't care about the y-intercept. All we were doing was talking about the concept of lines being parallel. But this line has to specifically pass through 2, 4. So the y-intercept needs to be specific because it's telling us, well, it has to pass through 2, 4. So the fact that it's parallel and the fact that it passes through 2, 4, I just wanted to focus on the fact that I want my slope to be the same. The only thing that will be different is my y-intercept. So if you look at, in black, I kept what I wanted. I wanted the y equals 4x. Now the y-intercept of plus 1 can go away because it's not going to cross at 1 if it's going to be parallel. Otherwise it's going to be the same exact line. So with the points 2, 4, my x is going to be 2 and my y is going to be 4. So when I substitute my values in, I can actually find my y-intercept from there. I substitute my 4 in for y and then my 2 in for x, and I still have my plus b. From here you're solving for b. You're trying to figure out what your y-intercept is going to be. So if I simplify the equation, 4 equals 8 plus b, subtract 8 from both sides, and now my new y-intercept is negative 4. So the line that is parallel to the given line above and that passes through 2, 4 has a y-intercept of negative 4. So then my answer, my final answer, the equation that is parallel to the given line and passes through 2, 4 is y equals 4x minus 4. Please write down any questions that you have, how, why, where, and then we'll ask that in class the next day. Alright, the second cutout that you have, you're going to title perpendicular lines. Now if two non-vertical lines have the slopes that are opposite, reciprocals, then the lines are considered perpendicular. We need to focus on first of all, what opposite reciprocals mean. Let's take the breakdown. Opposite, so if we have a slope of 1, opposite of that would be -1. Now reciprocal, we have to flip the fraction. So we have a couple examples on the bottom left for opposite reciprocals. Let's say that we have 1/2. Now the opposite reciprocal of 1/2 would be a -2/1. Notice how my signs are opposite and my fraction is flipped. Now with another example, let's say I have -5/4. Now the opposite reciprocal of -5/4 would be a +4/5. Those two are examples of opposite reciprocals of one another. Alright, so we have our given line of y equals -2/3 x minus 2. Now, the two lines beneath it are going to be perpendicular. We have to come up with lines that are perpendicular to the given line. Well, our focus is the fact that our slope is -2/3. The opposite reciprocal of -2/3 would be a +3/2. Well, let's first graph our given line in green. So we have a y-intercept of -2, and then we're going to go down 2/3 in the positive direction, down 2/3, so then you can see that our slope is negative. Now, line 1 is going to be perpendicular to it, so then our focal point is a slope. Notice how it's -2/3. Our line that's perpendicular to the given one needs to be the opposite reciprocal. It has to have the slope that is the opposite reciprocal of -2/3. So our slope of line 1 will be a +3/2. And then I just made up a y-intercept of +3, and then we're going to graph that on our coordinate plane. Same thing with line 2. Our slope has to be a +3/2. So then our y-intercept is -1, for example, and we graph that on the coordinate plane as well. Now, one thing that you need to point out, or that I need to point out to you, is when lines are perpendicular, a certain angle is formed. When we graphed line 2 on the coordinate plane, when it intersected the green line, which is the original given line, it created a right angle, which is a 90-degree angle. Now the same thing happened with the blue line. When the blue line intersected the green line on our coordinate plane, it also created a 90-degree angle. That is the definition of perpendicular lines. If your lines do not intersect and create a right angle or 90-degree angle, they are not perpendicular. Alright, example number 2, determine parallel or perpendicular lines. Determine which lines of the following lines, if any, are parallel or perpendicular. Well, every single time we need to have our equations written in slope-intercept form. This is probably the easiest way to determine our slopes and our y-intercept when our equations are in slope-intercept form, which is y equals mx plus b. So I'm looking at line A. And line A is currently in standard form, but I need my equation in slope-intercept form. So I'm going to do this in red. I'm going to write down my equation, 12x minus 3y equals 3. And so because I'm turning this into slope-intercept form, I'm going to subtract the 12x from both sides. And I'm left with -3y equals 3 minus 12x. Now because this is not in slope-intercept form yet, because the y is not all by itself, I'm going to divide both sides by -3. Now when I simplify the equation further, I have y equals a -1 plus 4x. Still, everything's all simplified, but it's not in slope-intercept form. I'm going to switch my -1 and my 4x position. So I have y equals 4x minus 1, and now we are currently in slope-intercept form. Now I'm not determining anything yet. I don't know if they're parallel or perpendicular to one another. Right now I'm just trying to determine what the slope-intercept form is of each equation. So then line B, luckily, y equals 4x plus 2 is already in slope-intercept form, so I'm just going to write that down. And I bet you can make a conclusion about line A and line B, but I don't want you to yet. Let's look at line C. In line C, we have 4y plus x equals 8. So right away I'm going to subtract my 4x from both sides, which leaves me with a 4y equals 8 minus x. Close, but I'm not yet in slope-intercept form, so I'm going to divide both sides by 4 and simplify and get y equals 2 minus 1/4 x. Stupid hand is in the way. That says y equals 2 minus 1/4 x. We're not in slope-intercept form, so I have to flip-flop my negative 1/4 x in positive 2, so that I have a y equals negative 1/4 x plus 2. Now I have all three lines in slope-intercept form. Now if you just look at all three equations, well, the red and the blue have the same exact slope, which means that they are parallel to one another. And if you look at line C, the slope is negative 1/4. If you compare the slopes of 4 and negative 1/4, well, those are opposite reciprocals of one another. So then we can conclude that line C is perpendicular to line A and B. Alright guys, hopefully you're taking notes, and make sure that for this you try now, you try this on your own. So pause the video, and then when you're ready to see what the answers are, press play, and then I'll give you all the answers. So take this, try this one on your own. Alright guys, the last example, example number 4, we are writing an equation of a perpendicular line. So we have to write an equation of the line that passes through negative 3, comma 4, and is perpendicular to the line y equals 1/3 x plus 2. So it has to pass through negative 3/4, which means that we're going to have potentially a different, actually we are going to have a different y-intercept, and our slope's going to be different because it has to be perpendicular. So then we know that the opposite reciprocal of 1/3 is going to be negative 3. That's what our slope has to be if it's going to be perpendicular to our given line. So then in y equals negative 3x plus b, we're going to have a new y-intercept. So that's our base. So it has to pass through negative 3/4. I'm sorry, negative 3 comma 4. So we substitute what we know as 4 is y, and negative 3 is our x. So we have 4 equals negative 3 times negative 3 plus b. Simplify the equation. And now we're solving for b. Subtract 9 from both sides. And now our y-intercept is negative 5. So then our equation is y equals negative 3x minus 5. This line that is boxed in red is perpendicular to y equals 1/3 x plus 2. And it passes through negative 3 comma 4. Like always guys, thanks for watching the video. Make sure you guys take good notes and ask great questions the next day. And thank you very much. Have a good day guys.